In this video, I will give a demonstration of how to use the Multipass CCS refiner. This application was designed to assist cyclic ion mobility users with creating calibration curves for Multipass CCS measurements. The application is available online at the link highlighted on screen, or can be downloaded and run locally from the Fernandez Group GitHub page. When running the application locally, it is important to save all scripts to a folder accessible by the working directory and to run the application from the app.r script. When I run the application locally, the first tab of the graphical user interface contains introduction information, including a brief background about the application, detailed instructions for using the application, as well as a list of citations. In this video, I'll be using the example files from the Using the Application section for creating a calibration curve, entering experimental data, and deconvoluting arrival time distributions with multiple peaks. We can create a calibration curve from the second tab of the application. I can enter information specific to my calibration in the text boxes provided, with compound names and CCS values separated by commas. For this calibration curve, I will use the example document from the first tab, which was created from water's major mix, using direct infusion electrospray ionization in the positive ion mode. Analyte names and CCS values for this example file can be found in the first tab of the calibration curve example document. I can upload a .xls file containing arrival times distributions from my calibration experiment, which I have copy and pasted directly from the Waters MassLink software. When I am ready, I can click the Run button and the application will fit Gaussian peaks to arrival time distributions, calculate perturbation corrected periodic drift times, count the number of passes for each standard in my calibration mixture, and ultimately construct single pass and perturbation corrected calibration power curves. This process usually takes under a minute, and a progress bar at the bottom of the screen will indicate the amount of time remaining. Once completed, results are displayed at the bottom of the screen, and calibration curves, or all plots used to create the calibration curves, can be downloaded from the two download buttons at the bottom. I can save my calibration curve to either of the two calibration curve slots, and use these calibration curves to calculate experimental CCS values. I can enter my experimental data in the third tab of the application. Here I can select which saved calibration curve I want to use and choose whether or not I want to compare my results to other collisional cross-section values. For this example, I will compare collision cross-section values from Splash 2 Lipido-Mix standards, determined by the application, to collisional cross-section values sourced from the McLean compendium. After my experimental perturbation corrected periodic drift times have been calculated, my results will appear in the data frame at the bottom of the page. I can download plots for individual analytes using the drop-down menu as shown, or I can download all plots. To further streamline the calibration process for non-isomeric species, the application automatically identifies the most intense peak within each arrival time distribution. For complex spectra with multiple mobility features, the Multiple Peak Arrival Time Distribution tab enables users to deconvolute up to 10 separate arrival time distributions per spectrum. Selected peaks can be copied directly to the clipboard for future analysis. In this example, I will fit the major and minor mobility features of two prostaglandin isomers and create separate arrival time distributions, which can be pasted directly into a formatted .xlsx document for calculating perturbation-corrected CCS values. Once I've entered my guess values for my Gaussian distribution, I can generate my final arrival time distribution plots and retain the data that I wish to copy by using the selected peak to copy and keep data within buttons. I can view saved calibration curves in the Calibration Curve 1 and 2 tabs and change plot settings using the Settings tab. In the comments section of this YouTube video, you will find the original paper, the link to our GitHub page, and the link to access the Multipass CCS Refiner online.